Jai Hind everyone. I am Dr. Anand Tyagi from Ajay Kumar Garg Engineering College. Today I deliver lecture on the topic vector differentiation for Engineering Mathematics 1 called BAS 103. And today contents of the lecture are, first of all, I explain what is gradient of the scalar point function and then divergence of a vector point function. First of all, I explain today lecture what is divergence and what is the role of divergence in engineering and technology, and explain what is vector point function and what is curl and role of the curl in our engineering and technology in future, and some application of the above topic covered today lecture. And after this I explain what is a directional derivative and what is the role of directional derivative in the role of modern age of science and technology. And after this I solve some question based on the above topic. And contents of today lecture are covered by the book AKGEC, Advanced Engineering Mathematics, John Ville, Marin G. Ware, B.B. Ramanna and B.S. Grewal. Student can be opt any one of them for the suggestion of the solution of the some problem and the as a reference. First of all, I explain what is point function. A variable quantity whose value at any point in region depend upon the position of the point is called vector point function. And role of vector point function is defined very briefly today. There are two types of function. First of all, scalar point function, and second is vector point function. Scalar point function is defined by the curve and vector point function is defined by the vector quantity at a particular point. And first of all, I explain here what is scalar point function. To each point P in 3 dimension in a region R in the space, there corresponding a unique scalar function f is, that is called a scalar point function. And scalar point function is calculated with the help of the vector quantity. I explain it briefly. And for the example, the temperature distribution of the heated body. When a body was in the fast in the automation, then body heated due to the temperature, and that is called as heated distribution. And density of a body and potential due to the gravity of the example of the scalar point function. Vector point function. First of all, I explain what is vector point function and then I elaborate it. If each point p, x, y, z in the region space the corresponding of a unique vector fp, then fp is called vector point function. Example, the velocity of a moving fluid, gravitational force are the example of a vector point function. In our body and blood is flow, that means blood flow is the vector quantity. In the same way, vector differential operator here, right? So first time introduced by the mathematician and calculate the vector differential operator, and that is known as differential operator. Suppose in a 3D object, I explain here, this is x-axis and this is y-axis and this is z-axis. In the direction of x-axis, vector use I cap. In the direction of y, use j cap. In the direction of z, use k cap. If all particle moving towards the x-axis in the space, that is denoted and defined by del over del x. In the direction of y-axis, denoted and defined by del over del y. In the direction of z-axis, denoted by del over del z. Suppose we combine all these together, that is known as operator, differential operator. And I explain here what is the role of differential operator here very briefly. So in this way, we generate a new operator that is known as differential operator. I explain here very briefly, right? How to use the differential operator, and that is denoted and defined by del operate is equal to I del over del x plus j del over del y plus k del over del z. In this way, we find the solution of the differential equation that is known as differential operator. And gradient of a scalar point function, and how to calculate gradient of a scalar function, and what is the role of gradient in engineering technology, I explain briefly here. First of all, I explain if phi z be a scalar function, then its gradient denoted and defined by grade phi, that is known as gradient of a phi scalar vector. How to calculate? and grade phi means del phi, and del operator is I del over del x, j del phi over del y, and k del over del z. In this way, this is denoted and defined by grade phi is equal to del phi. Suppose I take an example here. Suppose I want to take a plane and I want to calculate this grade phi. That means normal to the surface, right? This is normal to the surface. This is normal to my hand. That is known as the gradient of a hand. In this way, we can calculate the gradient of a scalar quantity by the example. How to calculate? I elaborate it. Suppose phi is a scalar point function. I want to calculate grade phi. Grade phi means unit normal to this surface phi at the point 1, -2 and -1. So I solve this by the first of all calculate gradient phi is equal to del phi, and then gradient of value is this and phi is this, right? Suppose I solve this. That means differentiate this portion with respect to x, differentiate this portion with respect to y, and differentiate this portion with respect to z. What is the differentiation of this function with respect to x? I write here 6xy plus 3x square minus 3y square z square plus k 2y cube z, and that is the differentiation with respect to x, y, and z here. In this way, we find the value of gradient of the phi and calculate at the point of 1, -2 and -1. In this way, we find the value of this function with respect to the gradient, that means normal to the surface. And after the calculation, we find here this is 12i cap minus 12i cap minus 9j cap minus 6l. And that is very interesting result. This is a vector quantity. That indicate gradient of a function will be a vector quantity. So we can say that gradient of a scalar point function is a vector quantity. That means with the help of gradient, we can calculate the vector n, which will be the normal to the given surface, right? Suppose I want to calculate here n cap, right? The value of n cap is equal to vector n upon magnitude of vector n. In this way, we can calculate the value of the unit normal to the surface in this way, right? How to calculate? I elaborate it very deeply. Another is geometrical meaning of the gradient. What is the meaning of the geometrical gradient? I explain in this lecture. The equation phi x y z is represent a family of surface for the differential value of the constant c. C contains all different value, right? So that is known as the gradient. That means normal to the surface. Del phi is a vector normal to the surface phi x y z. I just explain it, right? How to calculate del phi. Del phi means gradient phi and normal to the surface. I explain it by using the example. Find the unit normal to the surface. That is, this is known as phi, right? So first of all, I calculate here, right? Gradient means del phi with the help of this operator, and del phi putting the value of phi here, and differentiate these terms with respect to x, with respect to y, and with respect to z. And at a point, right, I explain here, right, -1, -1, 2, right? So normal vector will be this, right? We differentiate with respect to x, y, z, and put up the point -1, -1, and 2. And finally, I calculate this is a unit vector in the direction of normal to the surface. And how to calculate unit vector normal to the surface at this point? Del phi upon magnitude of del phi, put up the value of this. We can write in the form of n cap is equal to vector n and upon magnitude of vector n, right? That is known as unit normal to the surface, and result will be here 1 upon under root -11, right? I plus 3j minus k. In this way, we can solve the given problem. I take another problem. How to calculate the angle between the two surfaces? First surface is x square plus y square plus z square is equal to 9, and another surface is z is equal to x square plus y square and -3 at the point 2, -1, 2, right? So with the help of the gradient, we can calculate angle between two surfaces, right? So first of all, I calculate here, first surface is denoted by eta 1 and calculate gradient of this function with the help of differential operator, and with the help of differentiate, I put up the value of del and put up the value of eta 1 and calculate differentiate of x square is 2x, differentiate of y square is 2y, and differentiation of z is 2z. At the point 2 minus 1 2, we calculate here first vector, right? That is normal to the surface. Another vector consider here n2, right? Normal to the surface, and I calculate the gradient at the point 2 minus 1 2, right? That is known as the second vector. And we know that angle between two vector is eta 1 dot eta 2 is equal to magnitude of eta 1 and magnitude of eta 2 and cos theta, and apply here cos theta is equal to eta 1 dot eta 2 upon eta 1 and eta 2, and calculate the value and find the angle between two surfaces is cos inverse minus 8 upon 3 under root 21. In this way, we find the angle between two surfaces. Yeah, we can say that when two particles move in the space, then how to calculate the angle between them. And another topic is the directional derivative. How to calculate directional derivative? What is the role of directional derivative? The role of the directional derivative, when we find the position of a moving particle in the space, we find the directional derivative along the particle. The component of del phi in the direction of a vector is called directional derivative of a phi in the direction of a vector. How to calculate? I explained. Mathematically, the directional derivative is denoted and defined by del phi dot a cap, where a cap is the unit vector in the direction of a. So first of all, there are need of two components. First is gradient, and dot product with the identity matrix is called as the directional derivative. This is known as unit vector in the direction of a. Directional derivative. Another example of the directional derivative, we can say that another definition of the directional derivative is the rate of change of function in the specified direction. That is also known as a directional derivative. Use of the directional derivative in engineering and technology. The directional derivative is a rate which the function change at a point in the direction of given vector. If we are to find the rate of a function specified direction, we shall calculate the directional derivative. And I take another example here. Find the directional derivative of this function at this point in the direction of this vector. So first of all, we find here del phi dot a cap. This is known as dd. dd means directional derivative of the given function. In this way, we find out the value. How to? I explain here. So consider a function here square point function, that is x square yz and 4xz square. First of all, I calculate here the gradient, that means del phi, putting the value of del and putting the value of the square point function, and calculate here the differentiation with respect to x, with respect to y, and with respect to z at the point 1 minus 2 1. In this way, after the calculation, we calculate here vector n, that is known as vector n, j dot j plus 6 k cap. After the calculation, I want to calculate the directional derivative. Due to this reason, first of all, I calculate here a cap. A is the given vector. I divide magnitude of the a and I obtain here the a cap. Now our aim is calculate the directional derivative in the direction of vector a at this point. So how to calculate? Formula is this: del phi dot a cap. Putting the value of del phi and a dot here and calculate the dot product of two vector, and result will be here minus 13 by 3. In this way, we can find out the directional derivative of a gradient function with respect to the direction. What is the role of dd? We can calculate maximum value of directional derivative with the help of this. How to? Mathematically, directional derivative del phi dot a cap, where a is a unit vector and it is denoted by the dot product of two vector, and it is the maximum when the both vector are parallel. When both vector are parallel, then calculate the value of maximum value. Thus, right, A cap and del phi are the same direction. That means maximum value of the directional derivative occurs in the direction of del phi. Maximum magnitude of the directional derivative phi is known as greatest rate of increase and denoted by magnitude of del phi. Student, keeping in the mind, this play the very most important role in our engineering and technology. When we calculate the maximum magnitude, that means magnitude of the gradient of the phi. Find greatest rate of increase. I consider example here. How to calculate? I elaborate it. First of all, I calculate here phi, right? This is the given function, and after this I calculate here gradient, that means normal to the surface, with the help of this and this. After the calculation at this point, I obtain here the value of the del phi will be 1 minus 2 at 1 will be calculate here 6 k cap plus g. After the calculation, right, I want to calculate the greatest rate of increase del phi, right? That means magnitude of this vector, and magnitude of this vector student know how to calculate, right? Square root of the coefficient of j and coefficient of k. In this way we can calculate, this will be the 30 under root 37. So in this way we can find out the greatest rate of increase of any scalar point function. Now question is that what is the role of divergence and what is the divergence? I explain briefly today lecture. First of all, the divergence of a point function, vector point function, is denoted and defined by divergence f means del dot f. I explain here. Del dot, and del is the differential operator and f is the vector point function. So I suppose here f is a vector point function, f I cap plus f2 j cap plus f3 k cap. Then we can calculate here divergence f, and after the calculation we see that divergence f is a scalar quantity. So we can say that divergence of a vector point function is a scalar quantity. It is evident that divergence f is a scalar function. Physical meaning of the divergence is explained here. Physically, the divergence of a vector quantity represents the rate of change of field of strength in the direction of the field. Physical meaning of divergence is also denoted and defined by here very explainedly. If the divergence of a vector field is positive at a point, then something is divergence from a small value surrounding at the point. If it is negative, then something is converging into the small volume of the surrounding point. I explain by the diagram in the end of the today lecture. In this way, physical meaning of the divergence is denoted by this diagram. Suppose something is spread here, that is known as the positive divergence. Something is impressed here, that is known as negative divergence, and there is no output and no right, that is known as zero divergence. So divergence may be positive, divergence may be negative, and divergence may be zero. Physical meaning of the divergence by the example here, right? Suppose fluid is flow, the sometimes is, and that is the source of the fluid, and this is known as divergence of positive. And in this position there is no loss of fluid when fluid is passing through the 2 point, and there is no loss of the fluid, that is known as divergence, and that is known as solenoidal vector point function. And there is a negative because there is a split here, and there is a that is known as divergence of a negative point. Find the I consider here the another problem, right? Find the divergence of a vector point function, that is known as vector point function at the point of. So first of all, calculate here the divergence of this function, right? And after this, calculate this, and I show there the this is a scalar point function. So we can say that divergence of a vector point function is a scalar quantity. Now, role of the solenoidal vector point. A vector point is said to be solenoidal vector point if divergence is equal to 0. If divergence 0, that means there is no loss of fluid. That is also known as equation of continuity and comprehensible fluid. If there is no loss of the fluid, fluid is called comprehensible. If divergence is not 0, then that means fluid is incomprehensible. So, right? I show here the another example here. Show that this is the solenoidal. If divergence of this vector quantity will be 0, that means this will be solenoidal. So I calculate here divergence of del dot v. Del dot v means differentiate of v1 with respect to x, differentiate of v2 with respect to j, and differentiate v3 with respect to I write here, differentiate this portion with respect to x, that is 0. Differentiation of this with respect to y is also 0. Differentiation of this with respect to this is also 0. So we can say that given vector is the solenoidal. That means if fluid flow this curve, that means there is no loss of fluid and fluid is solenoidal. And the another example is the curl. And what is the curl? Curl means rotation of a vector quantity. When we drive a screw, that means we force in the direction of the wall, that is known as curl rotation. That means motion of the particle in rotation, that is known as a curl quantity, and denoted and defined by curl F means del cross F, right? And after the calculation, we see here the curl F is a vector quantity, right? And how to calculate? A student studied in the 12th level how to calculate the cross product of two vectors with the help of the determinant, right? I write here the ijk and component of the del vector and component of the force vector. After the calculation, we see that the curl of a vector quantity is also a vector quantity. How to calculate and what is the role of calculate? Suppose I want to calculate here the curl of given vector. So first of all, I calculate here del cross F, and with the help of cross by using this value and calculate the result. So I explain the today lecture what is the role of differential vector, what is the role of gradient, what is the role of divergence, and what is the role of curl. If a student have any problem today lecture, he can contact me. I solve their problem. I hope the today lecture play the role of very important role in your study. Thank you all.